Okay, so today we're diving into something really, really interesting in the world of large language models. And I think you're going to love this. As someone who follows all this stuff so closely, you know how much buzz there is around transformers.
Absolutely.
This architecture that's really come to dominate so much of what we see and use, in AI. But, and I think we both agree on this, every tool, no matter how powerful, eventually hits its limits.
Yeah, for sure.
You start to see the edges
Right.
and that's kind of where this idea of Mamba comes in, which is what we're diving into today. A totally different approach, selective state space model, it's called, that's sort of pushing those boundaries, kind of asking, okay, what else is possible?
Exactly. And especially for someone like you who's really interested in not just the what it can do, but like the core innovations, the theory behind how it works.
Yeah,
This
absolutely.
deep dive we're doing, it's perfect because we're looking at this big new study that really compares Mamba and Transformers head to head.
Yeah,
And we're going to get into the nitty-gritty, like what are the fundamental differences between them? How do they actually work?
right.
What does it tell us, as we push these models to larger and larger scales?
So before we get into the weeds, I think it's worth for anyone who maybe hasn't gone super deep on this, just to lay out one of I think, the most well-known challenges with transformers,
Sure.
which is that, they can be really computationally expensive.
Yeah.
Especially when you start dealing with these really long sequences of text. The more you feed in,
Oh,
the more the demands on the system just explode, right? It grows quadratically.
it's a huge problem, especially as we're trying to use these models for, longer and longer pieces of text.
Right. And then on the flip side, when you're actually using the model to generate text, you have this thing called the key value cache, right?
Right.
Which basically remembers everything it's seen so far.
It's like it's memory.
Exactly. And that thing just keeps growing linearly as you generate more and more words.
Yeah, it just eats up memory like crazy.
So you hit this bottleneck.
It's a resource hog, basically.
Yeah, like it just becomes really hard to scale. And
Exactly.
I think that's where the excitement around Mamba, at least initially, really stemmed from, right?
Right. And from a theoretical standpoint, what's so cool about Mamba is that it's designed to sidestep those limitations that you just talked about.
Yeah,
So think of it this way. Transformers, they try to look at all the words in a sequence simultaneously,
right, all at once.
all at once, and that's what gives them their power, but also leads to those scaling problems.
Right.
Mamba, on the other hand, it processes information more sequentially.
Okay.
It's like reading a book word by word, and it selectively remembers what's important over time.
Okay, so like it's choosing what to hold on to.
Exactly. It's being selective, and that's key to its potential for being way more efficient, especially with those really long context.
And those early studies with these smaller scale models, I mean, people were really excited
Oh, yeah, there's a lot of buzz.
because it was showing, hey, it can actually achieve the same or even better performance on these standard language tasks
Right.
with way fewer resources.
We're like, wow, maybe this is the future.
Yeah.
Maybe this is how we can finally get past these limitations with Transformers.
So that brings us to this new study, which is really where the rubber meets the road, right?
Right. And this is where it gets super interesting for people like us who are interested in where this field is going. Like, theoretically,
Yeah, definitely.
because, those early studies were promising, but the big question was, okay, but how does this thing scale? What happens when you actually try to build a really big Mamba model?
Right, because it's one thing to show it works on a smaller scale, but if
Exactly.
it doesn't scale, then it's not really going to be practical, right?
So this study, it's amazing. It's super rigorous. They took 8 billion parameter models. So we're talking big models here.
Okay.
They had Mamba, they had an improved version called Mamba-2, and then of course they had a transformer as the baseline.
Okay.
All trained on the same massive data sets, up to 3.5 trillion tokens.
Trillion. Wow.
Yeah, so we're talking huge amounts of data here.
Okay, so a controlled environment.
Exactly. Apples to apples comparison, which is what you want to really see how these things stack up.
Right.
And this is where I think it gets really cool. They also threw in a hybrid approach,
Okay.
which is kind of like taking the best of both worlds and seeing what happens. And that, I think, for someone who's interested in the innovation side of things, that's really where the fireworks start.
So our mission today is to kind of unpack this whole study.
Yeah.
Really focus on what makes Mamba innovative, how it compares to transformers, and then this whole idea of hybrid architectures, which
It's a whole new landscape.
Yeah.
It's fascinating.
So let's start with, you've got these pure Mamba models and you've got the transformer.
Right.
What did this study tell us about just their fundamental ability to understand language?
So what's amazing from a purely theoretical perspective is that on a whole bunch of standard language tasks, things that test common sense, physical reasoning, sentence completion, complex reasoning,
Yeah, yeah, like the standard benchmarks.
the pure Mamba and Mamba 2, they actually matched or even beat the Transformer on a lot of them.
Wow, okay.
And this is huge because it shows that these alternative architectures, they're not just about efficiency, they can actually achieve state-of-the-art language understanding.
So it's not just a trade-off, it's like a different way of getting there.
Exactly. It challenges the whole idea that attention is the only way to achieve this level of performance.
That's a really big finding.
Yeah, it's super exciting.
Okay, so that's like the good news. Now,
Right.
tell me, where did they start to hit some snags?
Right. And this is where it gets interesting because it really gets into the differences in how these models think?
Yeah.
So one of the big challenges that they found was on tasks that require really strong copying ability.
Okay.
Like imagine you have this huge phone book, right? A list of names and numbers.
Right.
And the model has to remember a specific number.
Okay.
The Transformer, it's amazing. It can do that with almost perfect accuracy, even with really long lists up to its limit.
Okay.
But Mamba, once you get past about 500 tokens, its performance starts to drop off pretty sharply.
Wow. Okay, so that's a pretty big difference.
Yeah, it is.
So what's going on there? Like, why is it struggling with that kind of task?
So what they found was that the SSMs, they have this thing they called fuzzy memory,
Okay.
which means instead of remembering the exact number, it'll often predict something similar, but not quite right.
Interesting.
And I think the insight here is that because Mamba processes information sequentially, it might not be as good at just directly grabbing a specific detail
Oh,
from a long context compared to the Transformer, which can kind of jump around and focus on any part of the input.
so it's like Mamba has a good general sense of things,
Right.
but when you need to pinpoint something really specific,
It's not as sharp.
it kind of gets blurry.
Exactly.
Okay, that's interesting. And then what about in-context learning? Because that's another area where Transformers have shown some pretty remarkable abilities.
Absolutely. And this is another key difference between the architectures that played out in the results. They looked at the 5-shot MMLU benchmark,
Okay.
which is a big test of knowledge across lots of different domains, and you only get 5 examples to work with.
Okay.
So it's like a quick learner test.
Yeah.
And after training on 1.1 trillion tokens, Mamba 2, it was way behind the Transformer, like about 17 points lower in accuracy.
Oh, wow.
Yeah, and even after training on the full 3.5 trillion tokens, it still didn't quite catch up.
Interesting. Okay.
So it seems like pure SSMs, they're just not as efficient at using those few examples to quickly adapt to a new task.
So it's like it needs more time to bake, more data to really get there.
Yeah, it's not as quick on its feet.
But there was this interesting twist in those MMLU results, right?
Oh yeah, this is where it gets really fascinating for understanding these models.
Yeah.
So they actually evaluated MMLU using 3 different formats. You have your standard multiple choice, then you have this weird one called choice text and targets,
Okay.
and then you have close eyes, where the model has to fill in the blank in a sentence.
Got it.
And get this, while the SSMs struggled with the multiple choice versions, they actually did better than the Transformer on the closed version.
That doesn't make sense.
It's kind of mind-blowing, right?
Yeah.
Because it suggests that Mamba might actually have the same knowledge as the Transformer,
Okay.
but it's just not as good at mapping that knowledge to the specific answer choices in a multiple choice format.
So it's like it knows the answer but can't quite express it in that specific way.
Yeah, it's like it has the knowledge, but it's struggling to articulate it in that particular way.
Now, why is that?
The authors, they think it might be because of how Mamba processes information sequentially.
Okay.
So it might be harder for it to directly focus on and weight the relevant information for a specific answer.
Compared to the Transformer, which can just look at everything at once.
Exactly. The Transformer, it can just zoom in on what's important for that specific question.
So it's almost like a difference in how they access and use their knowledge.
It is, and it highlights how the architecture of the model and those fundamental choices you make about how it's built, they can affect not just what it learns, but how it can express what it knows.
That's a really important point. Okay, so we've got pure Mamba. It's got these efficiency advantages.
Right.
But it's hitting some roadblocks with certain types of tasks.
Right.
So that brings us to this idea of hybrid architectures.
Yeah, this is where things get really innovative.
What was the thinking behind going in that direction?
So basically, they saw these limitations with the pure Mamba, and they thought, okay, how can we keep the good stuff like the efficiency, but also bring in the strengths of Transformers?
Okay.
And the answer was to try and combine them to create this sort of hybrid model that takes advantage of the best of both worlds.
So it's like, okay, we've got these two tools.
Right.
They each have their strengths and weaknesses.
Yeah.
So let's see if we can blend them together and get something even better.
Exactly. It's about creating a synergy between the two architectures.
So how did they go about actually designing this Mamba-2 hybrid?
So they took a really systematic approach. They started with smaller models and did a bunch of what are called ablation studies,
Okay.
which basically means they tried out different combinations of layers.
Okay.
Like how many attention layers should we add? How many Mamba layers?
Yeah.
And they were looking for the combination that gave them the best performance.
Right. So it's like tinkering with the recipe.
Exactly. They're like chefs in the kitchen trying to find the perfect blend of ingredients.
And what do they find?
So they found that adding just a small amount of attention, like around 8% of the total layers, was enough to significantly improve the model.
Only 8%.
Yeah, it's surprisingly low, right?
So it's like a little bit of attention goes a long way.
Exactly. It seemed like even a small amount of that global context awareness from attention is enough to really boost the performance of Mamba.
Okay, so that's attention. What about MLPs?
Right, so they also experimented with the ratio of MLP layers, which are those fully connected layers that are really good at learning complex patterns.
Okay.
And they found that a sweet spot was between 30% and 50%.
Okay.
And what's interesting is that the higher the MLP ratio, the faster the model trained.
Oh, okay.
So that's a nice bonus.
Yeah, definitely. So they're kind of figuring out the optimal mix of these different ingredients.
Exactly. And this is something I think you'll appreciate, they found that these hybrid models didn't need explicit positional embeddings.
Oh, interesting.
Which are these special tokens that transformers use to keep track of word order.
Right, right.
It turns out that the Mamba layers were able to learn that information on their own.
So it's like it's baked into the architecture.
Yeah, it's like it's inherently able to understand the sequence of words without needing those extra clues.
That's pretty cool. So what did the final 8 billion parameter Mamba-2 hybrid look like?
So it had 56 layers in total. Only 4 of those were attention layers.
Okay.
And they used a special type of attention called group query attention, which is more efficient than the standard kind.
Got it.
Then the bulk of the layers, 24 of them, were Mamba-2 layers.
Okay.
And then the rest, 28 layers, were MLPs.
Okay.
And they were all distributed pretty evenly throughout the model with a Mamba layer right at the beginning.
Okay, so now the big question, how efficiently could you actually train this thing? Because Mamba is inherently sequential.
Right, and that was a concern.
Can you actually take advantage of the parallel processing power that we have today?
So they look at something called model flop utilization, or MFU.
Okay.
Which basically measures how well you're using the hardware.
Yeah.
Are you actually making the most of those powerful GPUs?
Got it, got it.
And what they found was that the Mamba-2 hybrid had an MFU of 29.9% on NVIDIA H100 GPUs.
Okay.
Which is almost identical to the 30.7% they got for the 8 billion parameter transformer.
So that's good. That's comparable.
Yeah, it's basically saying that these hybrid models, they can be trained just as efficiently as transformers at that scale.
Okay, so that's a big win for practicality, right?
Absolutely.
You can actually use these things.
Exactly.
And what about the other big promise of Mamba, which is that faster inference, especially with long sequences? Did the hybrid model deliver on that?
So based on their estimates, it looks like the hybrid model could be up to 8 times faster than the transformer when you're generating text with a batch size of 32.
Wow, okay.
And that speed up, it comes from the fact that Mamba is just more efficient at processing those long sequences.
Right, because it's not trying to look at everything at once.
Exactly. And then there's also the potential for using larger batch sizes during inference, which would further boost the speed.
Okay, so it's ticking all the boxes in terms of efficiency.
It is, and that's really exciting for real-world applications.
Yeah, absolutely. Okay, but at the end of the day, it all comes down to performance, right?
Right, right.
Like, how did it actually do on all these different language tasks?
So this is where the magic of the hybrid approach really shines through.
Okay.
They took that 8 billion parameter Mamba-2 hybrid, trained it on the full 3.5 trillion tokens, and then tested it on those same 12 standard language tasks.
Okay.
And get this, it outperformed the 8 billion parameter transformer on every single one.
Wow, a clean sweep.
Yeah, and the average improvement was 2.65 points.
So that's a significant jump.
It is. It's a real step forward.
Okay, so it's doing better across the board.
Yeah, and it's not just a tiny improvement. It's a meaningful difference.
What about MMLU? Because we talked about how the pure Mamba models struggled with that a bit.
Right, and this is where the hybrid really shines.
Okay.
It actually showed a 3.5-point improvement on the 5-shot MMLU compared to the transformer.
Okay, so we closed that gap.
Yeah, it seems like those attention layers really helped to address the limitations we saw with pure SSMs.
Right, so it's like each architecture is contributing its strengths to the mix.
Exactly. Now, they did note that the transformer still had a slightly steeper learning curve, meaning it improved more quickly when you gave it more examples.
Okay,
So there might be something about attention that makes it a bit more efficient in those pure in-context learning scenarios.
interesting. So there's still room for investigation there.
Yeah, for sure.
Okay, now, one of the big things about Mamba was this promise of handling much longer contexts efficiently.
Right, that was one of the main motivations.
So how did the hybrid model do when you pushed it to 16,000 and 32,000 tokens?
So what they did was they took the base 4,000 token models and continued training them on those longer sequences.
Okay,
But first, they made sure that this didn't mess up their performance on the shorter tasks.
okay, so no regression.
Exactly. They actually saw a slight improvement, probably from the extra training data.
Okay, that's good.
Yeah, it's important to check that because sometimes optimizing for longer contexts can hurt you on the shorter stuff.
Yeah, absolutely. So then what happened when they tested these long context models?
So on the natural long context tasks, both the hybrid and the transformer benefited from those bigger windows.
Okay,
But the transformer still had a slight edge on average, especially on tasks that involved understanding multiple documents.
okay,
The authors, they think this might be because the way Mamba represents information in its state, it might get a little confused when you throw a bunch of documents at it.
okay.
And they also noticed that it was a bit sensitive to how you format the input, the prompt.
Interesting.
So there's probably still some work to be done there to make it more robust to those variations in natural language.
Right, so when it's more controlled, it does really well.
Exactly.
But when you're dealing with this messier real-world data,
Yeah, it's a bit more finicky.
it needs some fine-tuning.
Right.
Okay, but what about those synthetic long context tasks? The ones designed to specifically test information retrieval? Because I remember the hybrid doing really well there.
Oh, yeah, this is where it really stood out.
Okay.
So these were tasks from the ruler benchmark, including these really tough needle in a haystack tasks, where
Right.
you have to find a tiny bit of important information buried in a ton of irrelevant stuff.
Yeah.
And the Mamba-2-Hybrid just blew the transformer out of the water.
Okay.
It was significantly better at finding and pulling out that key information across really long sequences.
So when it comes to that specific task of searching through a lot of data,
It excels.
it's got a real advantage.
It does, and that has big implications for things like search engines, question answering systems, anything where you need to sift through massive amounts of data.
Yeah, absolutely. Okay, and what about that phone book task again, but this time with these long context models?
So remember how the pure Mamba models started to struggle beyond 500 tokens?
Yeah.
Well, both the 16,000 and 32,000 Mamba-2 hybrids, they were able to do the phone book task perfectly, even with lists that were way longer than what they were trained on.
Wow, okay.
And the transformer, as you might expect, it started to fall apart as the list got closer to its training limit.
Right.
But what even crazier is that they tested a 128,000 Mamba-2 hybrid,
Okay.
and it was able to handle phone books with over 150,000 tokens without a single error.
Wow. So it's like it learned how to generalize that ability to even longer sequences.
Exactly. It shows you something really fundamental about how these hybrid models learn and remember information.
Yeah, that's impressive. Okay, so to kind of wrap things up, what are the big takeaways from all this?
So I think this study has a couple of really profound implications for the field. First, it shows that Mamba is a legitimate contender in the world of large language models.
Okay.
It's efficient, it can achieve impressive performance, but it also has its limitations, which we need to be aware of.
Right. No model is perfect.
Exactly. Second, and this is probably the most exciting part, is that these hybrid Mamba transformer models are the real deal.
Okay.
They're not just a gimmick. They offer a way to combine the best of both worlds and achieve something truly remarkable.
Right. So it's not just about picking one over the other.
It's about finding that sweet spot.
It's about the synergy.
Exactly. And I think this study is just the tip of the iceberg.
Yeah, it feels like it opens up so many new questions.
It does. It's like a whole new frontier of research.
Absolutely. And the authors themselves, they highlight some of those future directions, right?
Yeah, they talk about optimizing these hybrid models for even more complex, long context understanding, especially in real-world scenarios where the data is messy and unstructured.
Right.
And they also talk about making them more robust to different prompt formats.
Okay.
Because we saw that they could be a bit sensitive to that.
Right.
And then, of course, there's the whole question of data efficiency and scaling.
Yeah.
Like, how far can we push these things?
So I guess the big question for everyone listening is, are these hybrid architectures the future?
That's a big question.
Right. Are we going to see a shift away from pure transformers?
It's possible.
Especially as we're dealing with longer and longer contexts, and the need for efficiency is just becoming more and more pressing?
Right, especially in real-world applications where you don't have unlimited resources.
Exactly. So something to really think about, this balance between innovation and what's already established.
Yeah, it's an exciting time to be in this field, that's for sure.
Absolutely. And for those of you who want to explore this further, the researchers have made their models and code publicly available,
Yeah, they're encouraging people to play around with it to see what they can do.
which is fantastic. So this deep dive into Mamba and these hybrid models, it's just a glimpse into what's happening at the cutting edge of AI.
It's a glimpse into the future, really.
Yeah, and it's a future that's full of possibilities.
That's
Well, thanks for joining me for this deep dive. Until next time.